Welcome to the final part of VCAA Specialist Math 2022 exam papers. In this video, we will solve exam paper 2, section B, question 6, which consists of 6 parts. In part A, some incorrect responses involved hypotheses for two-tailed tests, and most students did both part A and B well. Part C was generally done well, but some students did not justify their response with reference to the p-value. Students generally respond well to Part D. However, some transcription errors were apparent. For example, giving 14.59 as the answer. In Part E, most students understood that the difference meant that D is greater than -3 but less than 3. However, some students stated a correct conclusion but did not give a reason by referencing the p-value. In Part F, many correct responses worked directly in terms of mass with probability of the distribution that the mass is less than 375 times 1.04. Welcome to this VCAA Specialist Math exam paper series. This is section B of 2022 exam 2 paper. There are total 6 extended response questions in section B. In this video, we will present the last extended response question in section B. In question 6, it says there is a company producing soft drinks in aluminum cans. The company sources empty cans from an external supplier who claims that the mass of aluminum in each can is normally distributed with a mean of 15 grams and a standard deviation of 0.25 grams. A random sample of 64 empty cans was taken, and the mean mass of the sample was found to be 14.94 grams. Uncertain about the supplier's claim, the company will conduct a one-tailed test at the 5% level of significance. Assume that the standard deviation for the test is 0.25 grams. There are 6 parts in this question, and part A is to write down suitable hypothesis H0 and H1 for this test. Part B is to find the p-value for the test. The question in part C is to ask if the mean mass of the random sample of 64 empty cans support the supplier's claim at the 5% level of significance for a one-tailed test. Part D is to find the smallest value of the mean mass of the sample of 64 empty cans for H0 not to be rejected. Let's continue to read out question 6. Now the equipment used to package the soft drink weighs each can after the can is filled. It is known from the past experience that the masses of cans filled with the soft drink produced by the company are normally distributed with mean of 406 grams and a standard deviation of 5 grams. Under such circumstances, the question of part E is to find the probability that masses of 2 randomly selected cans of soft drink differ by no more than 3 grams. In part F of this question, 1 milliliter of soft drink has a mass of 1.04 grams. Assume that the empty cans have a mean mass of 15 grams and a standard deviation of 0.25 grams. Then the question is to find the probability that a can of soft drink selected at random contains less than 375 milliliters of soft drink. Now, let's come back to part A of this question, which is to write down suitable hypothesis H0 and H1 for this test. Hence, no hypothesis H0 assumes that the mean mass of the sample cans is the same as before, which is 15 grams. while the alternative hypothesis H1 assumes that the mean mass of sample cans is less than 15 grams. In part B, the p-value is calculated by assuming the null hypothesis is true. Hence, p equals the probability when the distribution variable x is less than or equal to 14.94, given that the mean mass of the sample is 15 grams. After being standardized, the probability when z is less than 14.95 minus 15, or over the ratio of 0.25 to square root of 64, which approximately equals 0.027. As for part C of this question, according to the calculated p-value, which is 0.027, as well as the conventional table, since the p-value is less than 0.05, we may conclude that the test result shows it has good evidence against the null hypothesis. Since part D is to find the smallest value of the mean mass of the sample of 64 empty cans for H0 not to be rejected, we need to calculate the value of x, which is assumed to be the smallest value of the mean mass in grams. Hence, PR of z is less than x minus 15, or over the ratio of 0.25 to square root of 64, is greater than 0.05, which gives x minus 15, or over the ratio of 0.25 to square root of 64 is greater than negative 1.64485. Therefore, the smallest value of the mean is greater than 14.95. As for the question in part E, we assume the mass distribution variables of the two randomly selected cans of soft drinks are x1 and x2 respectively. The expected value of the difference of two randomly selected cans, E of x2 minus x1, equals E of x2 minus E of x1, which equals 0. However, the variance of the difference of two randomly selected cans equals the variance of x2 minus x1, which equals the variance of x2 plus negative 1, or in parentheses squared, times the variance of x1, which equals 50. Thus, the probability of the difference between negative 3 and 3 equals the probability when z is greater than negative 3 over square root of 50, but less than 3 over square root of 50 after being standardized. Hence, the probability equals PR of z is less than 3 over square root of 50 minus PR of z is less than negative 3 over square root of 50, which approximately equals 0.329. Here we come to the last part of this question. Before we start, we assume the distribution variables for the total mass of the soft drink, the mass of the empty can, as well as the mass of the net soft drink are x, y, and w respectively. Accordingly, the expected value of w equals the expected value of x minus y, which gives E of w equals E of x minus E of y, which equals 406 minus 51, which equals 391 grams. The variance of w equals the variance of x plus negative 1, or in parentheses squared, times the variance of y, which equals 25 plus 0.0625, which equals 25.0625. Hence, the standard deviation of w equals the square root of the variance of w, which equals 2.0062499. According to the question, we need to calculate the probability when W is less than 1.04 times 375, which equals PR of W is less than 390. After being standardized, PR of W is less than 390 equals PR of Z is less than 390 minus 391, all over the standard deviation of W, which approximately equals 0.421.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.